Deep space is an unforgiving environment. Every single gram of mass and millimeter of volume on a spacecraft has to justify its journey. Engineering for this environment is a strict zero-sum game of spatial economy. The Artemis program is pushing the boundaries of this math, tasked with sending a crew of 4 astronauts on continuous 21-day missions to the Moon and into the deep void beyond. To pull this off, NASA built the Orion spacecraft. It is the exploration vehicle designed specifically to transport and sustain a crew in the deep space environment, far beyond low Earth orbit. When you look at the interior dimensions, Orion actually offers just 30% more habitable space than its 1960s predecessor. In the vacuum of space, this 30% margin provides the specific physical budget required to transition from simple survival to active, long-duration habitation. We can see why this upgrade was necessary by looking at the Apollo command module. It was an absolute marvel of 1960s engineering that got us to the Moon, but the interior was severely limited. It could hold a maximum of 3 astronauts and was strictly capped at a 14-day flight limit. Inside this tight metal cone, the environmental control system could not compensate for the heat and sweat generated by a human workout, making exercise nearly impossible. Because astronauts could not perform these workouts or manage waste effectively over long periods, Apollo remained a short-term vessel, incapable of supporting sustainable habitation. When you extend a mission to 21 straight days, keeping the human hardware clean and functional becomes a primary engineering hurdle. Orion's extra volume houses the Universal Waste Management System. A dual-fan separator creates airflow, pulling waste safely away from the body in zero gravity. This expanded physical volume also allows for odor control filters, noise mitigation, and a privacy door. The remaining physical budget, paired with upgraded environmental controls, finally allows astronauts to perform full heat-generating workouts during the mission. Spending the spatial budget on hygiene and exercise fulfills a non-negotiable physiological requirement to prevent muscle atrophy and illness on multi-week missions. The moment a spacecraft leaves the protective shield of Earth's magnetic field, the crew is exposed to the invisible, lethal threat of deep space radiation. If the sun releases a sudden solar flare, it triggers a solar particle event. When that radiation hits, astronauts need immediate physical shielding to survive. Orion's extra volume allows astronauts to physically reconfigure the cabin. They can move dense cargo supplies to the least shielded walls, constructing a whole cabin storm shelter to create a radiation barrier. This internal flexibility provides an alternative to wearing heavy personal shielding, such as the Astrorad vests tested on Artemis 1. In spacecraft engineering, interior volume provides safety, giving crews the flexibility to adapt their environment to survive the hazards of the deep void. Engineers carved out this 30% extra interior space without drastically increasing the size of the exterior capsule compared to Apollo. While Apollo relied on a single massive flight computer, Orion uses 4 redundant systems operating simultaneously. These computers are 20,000 times faster and contain 128,000 times more memory. The heavy analog dials and mechanical switches were stripped out, replaced by a digital glass cockpit and software-driven avionics. Decades of computing miniaturization bought the physical real estate required to install life-saving human amenities. By creating a stable, sustainable environment, scientists can now conduct vital in-flight research, such as tracking immunity biomarkers in astronauts over long durations. Orion serves as a mandatory proof of concept for maintaining human health and safety in the deep space environment. Mastering the spatial economy inside this capsule is a prerequisite for building even larger structures, such as the Lunar Gateway Station. Successfully managing human survival within Orion's 30% margin is the foundational stepping stone required before humanity can attempt the months-long journey